If you clicked on this video, I'm guessing you wanted to set up your own NAS at some point. If I'm right, you're at the perfect place, because in this video I'll show you how to do it from beginning to end. I was stuck there for quite some time, thinking I need like 1000 high capacity hard drives, fast networking and a high performance PC. In practice, for a simple home NAS, none of this is needed, and a totally usable file server can be built using just a Raspberry Pi or even better, an old PC. Mini PCs are also a great option, but you can follow this tutorial using whatever you have available to you. By the end of this video, you should understand how a NAS works, what's required to build one and how to set it up. So let's build a NAS. First thing to cover is what it actually is and why would you even want to set it up for yourself. When talking about a small home NAS, you can imagine it as a physical USB drive that's connected to all of your devices at the same time. You can now drop a file from your PC and later access it from your laptop. Maybe upload some photos from your phone and download them to another one. In this video, I'll be setting up a Samba share, and it is similar to a cloud service like iCloud, Mega, Dropbox and similar. All of these services are easy to use and in most cases have a free plan, so why would you even want to build your own? Well, free plans come with a catch, and they usually limit you with very little storage, which in many cases won't be usable for anything serious. When you build a file server yourself, you can add as much storage as you want without any monthly fees. Next crucial thing is safety of your data. When you build your own NAS, you're in control and you can make it offline at any moment, so you don't have to worry about anyone else picking at your files. And the coolest feature of a home NAS is definitely this. For all of these services, you need some kind of an app or a browser to access your files, which makes, for example, editing a video from such a cloud impossible. The type of a NAS I'll be setting up in this video shows up as a normal hard drive across all of your devices, and the last video I made on this channel was actually edited from such a file server. This makes it easy to transition from one device to another while working on the same project, which is awesome. Everything is connected over the network, and when you first set it up, you will have to be connected to the same network as the file server to access it. This can be great if you don't plan to access these files from outside of your network. You can share movies to your TV, manage your photos for example, and work on projects from multiple devices. But such a NAS can easily be made public too, if that's what you're looking for. To access it from outside of your network, you can simply port forward it, but I wouldn't recommend this to anyone as it comes with great safety risks, and a better option would be to set up a VPN. OpenVPN is the way to go, but requires a bit higher IQ, so for the past 6 months or so I've been using Twingate. It's really easy to set up, and if there's enough requests, I may make a separate video on how to set it up. The cool thing about the NAS I'll be setting up in this video is that you can access it from all of your devices. That includes Windows, Mac, Linux, Android and even iOS. At this point I think I got your attention, so let me quickly thank the today's video sponsor, PCBWAAAAY. PCBWAAAAY is one of the biggest PCB manufacturers in China, and I have for sure seen some high quality PCBs from them in the past. The special thing with PCBWAAAAY is that they specialize in manufacturing complex PCBs, so if you ever need a board with some special features, PCBWAAAAY is the way to go. They also offer a lot of different services, and the most interesting one to me is definitely 3D printing. They can print in all sorts of materials like resin, nylon and even metal, which is just on another level. Upload your files, select the material and get your quote today. Make sure to check them out, and I'll leave a link in the description below. If this is your first time setting up something like this, I found it to be easier to follow if I show you all of the steps first, so you know what to expect and what's coming next. Then I can cover each one in more detail. So the first step would be to get our hardware ready. I run my NAS on my home server with a hard drive, but in this video I'll be setting it up on a Raspberry Pi, just for convenience. The whole process is exactly the same if you were using another Debian-based Linux distro, like Ubuntu server on a PC for example. An old laptop or everything else that can run Debian Linux will work too. If you don't have any extra hardware laying around, you can also follow this tutorial inside a virtual machine. I'll prepare the OS, and after the Pi is booted with PiOS Lite, I'll quickly set up a static IP address and start preparing my USB drive so I can use it as a shared drive on my network. In normal situations where you do have setup ports, you would use hard drives or SSDs, but in this case, since Raspberry Pi has USB ports only, I had to use a USB drive. As I already said, the whole process is exactly the same, so don't be afraid to follow if your setup is a bit different. After partitioning, formatting and mounting the drive, I will install Samba and configure it. Samba is an open source software which enables file sharing over the network. After configuring Samba, the NAS is practically done, and at that point I'll show you how to add it across all of your devices and how to use it at its full potential. First step when setting up a NAS is to get the hardware ready. Speaking of computing power, you need very little to run such a system. A Raspberry Pi is more than enough, but an old PC may be a bit better. The thing is that we are not really looking for computing power, but drive and network speeds. In my case, I don't have the latest and greatest Pi, but a 3B+. It's totally fine when you need to test such things out, and I always prefer installing new stuff on the Pi first, and then when I figure out how everything works, I move to my home server. The thing with my Pi is that it only has USB 2.0 support, which will drastically impact our NAS speeds. Speaking of speeds, let's talk about speeds. Your NAS read and write speeds will depend on two main factors, which are your drive and network speeds. Your drive can be a hard drive, SSD, a USB stick, SD card, or similar. In most cases, your network will be the bottleneck, so even if you plan to use an old hard drive, it will be just fine. Old laptop hard drives are very easy to find and are perfect for something like this. My last video was edited from a 1GB NAS running a single hard drive, and I didn't have any issues. Next thing is network speed. Every computer, a Pi, or a similar device you're going to use will need to have some kind of a NIC, which stands for Network Interface Card. A Raspberry Pi has an integrated one, same as every other PCB motherboard. Most of these come with a speed of 1 gigabit, which means they can handle around 125 megabytes a second maximum. To achieve this speed, you will need a Cat5e or faster Ethernet cable and a 1 gigabit network switch. All these components are pretty standard nowadays, so you don't really have to worry about them yet. So if I take a random hard disk, most of them come with a read and write speeds of around 100 megabytes a second, which is just around the same as our 1 gigabit network. I can go with an SSD instead, which has 5 to 10 times larger speeds, so 500 to 1000 megabytes a second, but it would be limited by our network, so it doesn't really make sense. As I said, in most cases your network will be the bottleneck, and if you want to go faster you will have to upgrade it. And the first thing you need to upgrade is your NIC. They come in PCIe forms most of the times, and that's why I said an old PC may be a better option. With a Pi you don't really have these upgrade options, and an old PC which may run 100 times faster will cost you only 1/4 of the price of a brand new Pi. An old PC may draw a little bit more power, but that's a topic for another video, and in my opinion it's not anything serious. 1 gigabit is standard, so if you want to go faster you could get something like a 2.5 gigabit card. A 2.5 gigabit card could handle around 300 megabytes a second, and at this point we are slowly getting close to SSD speeds. Please note that both server and the client need to handle these speeds, so if your NAS has a 2.5 gig NIC and your PC can support only 1 gigabit, you didn't really do anything. So all devices need to handle the higher network speed, and the network cables you use now need to be even faster, Cat6a or higher. But we are still not done, because if you want to connect multiple devices together, you will need an internet switch, which now again needs to handle these higher speeds. All this network equipment will cost you a lot, and that's what put me off from setting up my own NAS for a very long time. In practice, you really don't need these crazy speeds, because even a 1 gigabit NAS can be a lot faster than those cloud services I mentioned earlier. 1 gigabit switches can be found brand new for 15 euros, and Cat5e cables are dirt cheap. You won't need anything faster unless you're running some serious things and have a lot of people, like a video editing team, using the same NAS at the same time. If I was able to edit a half-an-hour video from such a basic NAS, there's really no point in spending lots of money when you're just starting out. So let's take a look at my setup. My main NAS is running on my home server, which I already covered in a video. 1 gigabit NIC, a hard drive, and that's it. In this video I'll show you the whole setup from beginning to end, and to do so I'll use my Raspberry Pi, because the whole process is the same and I can easily wipe it whenever I want to. My Pi will run a bit slower than my PC home server, but the whole setup is the same. As the main storage drive of my NAS, I'll have to use a USB drive, since this is my only option when using the Pi. USB 2.0 speeds are limited to 480 megabits, which is around 48 megabytes a second. Since my network is faster than that, we can expect our final speeds to be somewhere close. So a USB drive for storage, a network cable for connecting it to our network, and then to power the Pi I will need a power supply. Since I am one of those 3D printing nerds, I had to 3D print a small case in which I installed a small cooling fan to make the Pi run cooler. A Raspberry Pi boots from an SD card, so that's also something you will need. Make sure it's a faster one, and if you want to hear me speak about SD cards in depth, check out my DIY home surveillance video. To follow the later steps, you will need to have a Debian-based OS running on your device. In my DIY home server, I covered how to install Ubuntu server on a PC, and that will work perfectly for following this guide. With a Pi though, the best option would be to install Raspberry Pi OS Lite, as it's a less demanding system, and with a Pi, we are quite limited with resources. Take your SD card, backup everything and format it. Download the Raspberry Pi imager, install it, and start it up. click choose device and select your Pi. Then choose OS, select Raspberry Pi OS Lite, then choose storage and select your SD card. Double check that you selected the right one, and then we can enter settings by pressing Ctrl+Shift+X on Windows or Command+Shift+X on Mac. Make sure to enable SSH and set your username and password. Then you can change your time zone and keyboard layout if you want. Then click save, write, and wait for it to finish. While the imager is writing to the card, you will get some messages asking you to format the drive, but don't touch anything until the imager is done. Once it's finished, it will eject the card automatically, and when you see this message, you can remove the SD card from your computer. Now insert the card into your Pi, connect the network, and power it on. First boot up will take a bit longer, but once it boots up, the rest of the setup is the same as on Ubuntu server. Once your server boots up for the first time, we will need to access it, and since we don't have a separate display, keyboard and mouse setup, we will have to connect to it wirelessly via SSH. For connecting via SSH on Windows, I like to use an application called Putty, and on Mac, I can simply do it over the terminal. For an SSH connection, we will need the username and password we set in the earlier step, and the IP address of our server. To find the IP address, I will log into my router and try to find it there. Once we have our OS up and running, the first thing to do is to set a static IP address. Before doing any changes to our system, it's always a good practice to update everything, so I'll quickly run the sudo apt update command, followed by sudo apt upgrade to update all repositories on our system. If we leave everything as it is right now, the local IP address of our server will change almost every time we power cycle it. And since we will use this IP address to access our files, it would be much easier if it stayed the same. So to set up a static IP, we will need to change some config files. But an easier way is to simply assign it from a router. Each router interface is a bit different, but it should be straightforward, and this is how I do it. I enter the IP address of my router into my browser and log in. I go to all devices and find my Pi. Then I can click on the address type and change it to static by assigning a new address to my device. Click save, and that's it. Now my Pi has its own IP address, which will always stay the same. Let's reboot the Pi and check if the IP address is correct. It shows up with the new IP address on the router, and when I try to SSH into it again, everything works. Our server is now set up, and we can continue by setting up our drive as an SMB share. So, with our server running with a static IP, the first thing to do is to set up our main NAS drive. Connect it up, and to find it, we will use the lsblk command. In my case, it's a USB drive, but same goes for a hard drive or an SSD. Once the drive is connected, go back to the terminal and type lsblk. On my Pi, we can see two drives. One is MMC block 0, which is my SD card on which I installed the OS. You can see that its mount point is /boot/firmware, and you can easily differentiate it that way. We really don't want to touch this, so make sure you recognize your OS drive. The USB drive I just plugged in shows up as an SDA drive. It is currently not mounted and we can't access it. Before I do mount it, I would like to format it and partition it. To do that, I'll type sudo fdisk/dev/sda. SDA is the name of my drive, but yours could be different. Press enter and we are inside the fdisk utility. The utility says we can enter the m command for help, so let's do that. Here we can see a list of all commands, and the first thing I would like to do is to delete all partitions. I'll enter D, press enter, and the partition is deleted. Now we can repeat this step one more time, and if all partitions are deleted, you should get a similar message as I did. Once all of them are deleted, we can enter the W command to save changes and exit the fdisk utility. Let's try running lsblk one more time, and now you can see that my drive doesn't have a partition anymore. Let's repeat the fdisk command to create a new, fresh partition. I'll enter the N command to add a new partition. Partition type will be primary, partition number will be 1. First sector can be left as default, and you can do that by leaving it blank. Then for the last sector, I will do the same thing. The partition was created, and now we can enter the W command again to save everything and exit from the fdisk utility. Let's type lsblk one more time to confirm we did it right. Next step is to format the drive. We need to format it to ext4 file system, and we can do that with this command. To get rid of everything on screen, I'll type clear, and then I'll type lsblk one more time so you have it as a reference. The partition we want to format in my case is called SDA1. To format it, I'll type sudo mkfs ext4/dev/sda1. For creating journal, leave it blank and press enter. And that's it. The drive is now formatted to the ext4 file system. After partitioning and formatting, the next step is going to be to mount the drive to our system so we can access it. To mount the drive, we will first need to create a mount point. I already explained a couple of these commands in my home server video, but I'll cover them again. If you need anything else I didn't mention, ChatGPT will help you. So we need to create a mount point, which is basically a new directory inside the system, a basic folder, nothing special. We can use the cd command to change directory and cd ... to go back. ls command will list all files and directories inside the current one. Since I'm currently in my users directory, I will type cd ... a couple of times until I go all the way back. Typing clear will clean the screen, and typing ls will list all of the directories. If you can see home, temp, mount, etc., you are where you need to be, and now we can enter the mount directory by typing cd mnt. Let's do an ls and create our new mount point here. To create it, I will type sudo mkdir myusb. Mkdir command creates a new folder, and myusb is the name I gave it. You can name your directory differently, but since I'm using a USB drive, I decided to call it like this. Let's go back, and at this point we can finally mount the drive. Type sudo mount/dev/sda1 /mount/myusb. This command now mounted our USB drive to the mount point we just created. To check if you did it correctly, type lsblk one more time to see the mount point of our drive. It is correct, but every time you reboot the system, you will have to mount it again. So let's make that process automated. Type sudo nano/etc/fstab and press enter. At the end of the file, before the comments, add the following line, but make sure to change the path if yours are different. I will leave a list of all commands and configs I used in the description below. To save this config file, press Ctrl+X, then Y and enter to confirm. Now let's reboot the system to see if the drive gets mounted automatically. To reboot the system, you can simply type sudo reboot. After a couple of minutes, the system has rebooted, and now we can check if the drive is mounted by entering the lsblk command one more time. And as you can see, the drive is mounted. In the next step, we need to create a shared folder, which is simply a new directory on our drive, which will be shared over the network. At this point, this should be pretty easy, so let's go to our drive by cding into mount/myusb. ls command should return nothing since we don't have any files here yet. Create a shared folder by typing sudo mkdir shared and use the ls command to confirm. Now we will need to grant read and write permissions to this folder to all users on our system, and you can do this by entering this command. Our drive is fully set up, and at this point it's ready to be shared. To share it, we will need to install Samba. Enter the Samba install command, which will be down in the description, press enter and wait for it to finish. After Samba is installed, we can modify its config file and tell it to share our drive over the network. Modify the config file by entering sudo nano/etc/samba/smbconfig. Now scroll all the way down and add the following, but remember to replace your path if it's different. Press Ctrl+X, Y to confirm, and enter to close. Now for Samba to load our configuration, we will need to restart it. Type sudo systemctl restart smbd and press enter. Now we need to grant the drive access to our user, and to do that, do the following. Type sudo smbpasswda followed by your username and set your new password. And that's it, your NAS is up and running, and now let's see how to access it so we can have some fun with it. So with our NAS running, the next step would be to add it across all of our devices. Let's try to connect from Windows first, and to check if everything is right, I'll go back to the Pi and I'll create a new text file inside the shared folder, and I'll call it Hello World. You can create such simple files using the touch command. Now inside File Explorer, go to this PC and in the top edges bar type // your IP /shared. Enter your username and password if required, and we are inside the NAS. The text file is here, and now we can try to add a few more files to the drive. Each time you close this window, you will have to type the IP address again, so for the drive to stay under network locations, right click and select add a network location. Select choose a custom network location and enter the IP address same as before. Your NAS should now show up under network locations, and it will stay here until you remove it. Let's move to my MacBook to see how it's done in macOS. While on desktop, press Command+K and enter smd / your IP. Enter the username and password, select the shared folder and click OK. And you can see that all of the files are here. We can now try to add something else, and you can see it appearing on my PC instantly. Now let's add the NAS drive to my Galaxy S23. Go to My Files and Network Storage. Press Add Network Storage and Network Drive. Press Add manually and enter the IP address. username and password. Let's go inside the shared folder and you can see that everything is here too. When I'm using my NAS for my phone though, I found this app to work better. It's called CX File Explorer, and the cool thing about it is that now you can see the file thumbnails too. iPhones can also be connected, but none of mine are working, so sadly I won't be able to show you how to set it up. If you have an iPhone and are trying to connect, try searching for something like how to connect an iPhone to an SMB share. I'm sure there's a lot of videos that will help you set it up. And that's it, your NAS is set up and ready to use. Now you're ready to install it on your home server and you can use it as free cloud storage. Now you can play PlayStation games, watch videos from your TV, work on same projects from multiple devices, and use it as basic cloud storage like iCloud for example. I like having a NAS running at all times because if I'm in a situation where I quickly need to transfer some files and I don't have any USB drives, I can easily log in into my NAS, upload the files and be done with it. Once you install something like OpenVPN or TwinGate, your files will always be with you even when you're not connected to your home network. You will be able to download them whenever and wherever you want. TwinGate setup could be a potential idea for a future video, so if you want to see that, make sure to leave a comment. I really hope I helped some of you and show you that for something like this, you don't need a bunch of drives and expensive equipment. You can set up a pretty good NAS on any old PC and have it up and running in just a few hours. If I missed something and if you have any questions, let me know, and make sure to check the description because I'll leave all of the commands I used down below. If you enjoyed the video, don't forget to leave a like, and if you want to see more videos like this, make sure to subscribe to the channel.